Hello everyone, welcome to Infigyan. In this very exciting video of exponential equations, we will be solving an interesting equation 2 power x equal to 1 plus x square. Let me begin with, there are two functions. One is 2 raised to the power x exponential, another is parabolic x square plus 1. If you will see the graph of y equal to x square, simply if you will check, it is one symmetrical even function. It would be having minima at x equal to 0 origin. Okay. Now y equal to x square plus 1. Then I will shift the same graph 1 units upward. Vertex is still at height 1 unit or 0, 1 coordinate. Done. Now left hand side we are having graph a raised to the power x. So it will pass through. See, if I am putting x equal to 0 in 2 power x equal to 0, function is 1. So that means this point is 1. See, this point is also 1 where parabolic function is getting minima. So let me club both. I am showing in 1 only. One graph is e raised to the power x. Another graph is like this. See, it is not as symmetrical, but the graph would be like this. Now, point is how, see this point, the intersection, this point I am talking about at x equal to 0. Let me find out x equal to 0. This value is 1. Right hand side is also 1. That means both graphs are intersecting each other for very first time at x equal to 0. So this is the point 0, 1. Now if I will put simply by check and error method or inspection method or any other method, if I am simply putting x equal to 1, left hand side would be 2, right hand side would be 2. That means x equal to 0 is one solution, x equal to 1 is another solution. You can verify using intermediate value theorem also. So this is our second point, x equal to 1. Let me show you. Let me consider fx is equal to 2 raised to the power x minus x square plus 1. Okay. Now put x equal to 0. So it would be 1 minus 1, which is 0. So this value is coming out exactly 0. So conclusion is x equal to 0 is one solution. Similarly, if I will evaluate f of 1, I will be having 2 minus 2 equal to 0, which implies x equal to 1 is another solution. Now, is there any other solution possible after this x equal to 0 and x equal to 1? So yes, let us show the f of 2 value. See, if I am writing f of 2, then you will be having 2 raised to the power 2, 4 minus 2 plus 1. So that value will come out 1, so negative 1. Okay, this bracket is 3. So you will be getting negative 1 overall. Now 4 minus 5, so negative 1. F of 3, I am writing directly the values. Let me write f of 3. So 2 raised to the power 3 minus 10 minus 2, negative, negative. F of 4, 16 minus 17, negative 1. F of 5, see, check this value. 2 raised to the power 5, 32. 5 is square 25 plus 1, 26. See, it is coming out plus 6, positive, negative. That means there is one more solution, one more root is there in between 4 and 5. 4 and 5. Alright, so one solution x equal to 0 is confirmed, x is equal to 1 is confirmed, and the third one is in between 4 and 5. How we will find that? Because that is not any integer value. So we have to take the help of Newton-Raphson method. And this theorem, what we have done here, it is called intermediate value theorem. Intermediate value theorem, from where we can conclude whether your root is decimal root or solution is decimal solution, we can conclude in between two integers there is one solution for sure by changing its sign. F of A and F of B, if there is sign change in that value, then it is confirmed that in between A and B there would be one real solution. Okay, let's find out fx equal to 2 raised to the power x minus x square plus 1. Let's find out that third solution. F dash x would be 2 power x ln 2 minus 2x. Now I will use Newton-Raphson method formula. X of n plus 1 xn minus fxn over f dash xn. Okay, let's consider the first one because root is in between 4 and 5. So I will consider the first value with 4 base. So 4 minus f of 4 over f dash of 4. If I will put the value, then 4 minus negative 1, you can put the value and check. 16 ln 2 minus 8. So this value is coming around 4.3235. Then I will use second iteration. I will take second iteration. This value is coming out 4.2605. Third iteration, I am getting 4.2574. And we will get the final root, final solution after fourth settlement, after fourth iteration. That value is 4.257462 and so on. We will consider this x4 value as third solution of the given exponential equation. And how it is happening? After crossing that point, see, let me draw it. Let me use the same color. See, this one is the quadratic one. It is moving like that. And then this red color exponential curve will come and it will intersect. It will intersect and then it will cross like that. So this point, if you will observe, forget about this. This is 4.257. This one is x is equal to 1 and this one is x equal to 0. There are three solutions possible. And once it is crossing this one, it is not going to intersect further because the rapid growth of exponential, the parabolic won't match it. After it is crossing, means from x is equal to 5, 6, 7 and so on, it won't get intersection anymore. I have shown you the values in the Newton-Raphson method. See, let me show here x5, 6, 7. If I am putting x equal to 5, then 2 power 5 would be 32 and this value would be 26. 2 power 6, 64 and this value will be 37. You can see the rapid growth of exponential function. 2 power 7, that would be 128. It would be 50. 49 plus 1, 50. Now you can see the difference. How much faster the growth of exponential is if you compare with parabolic or quadratic equation. And this is we have seen in using Newton-Raphson method also. I hope you like this video. Thank you so much for watching. Please do not forget to like, share and subscribe. Bye bye for now.